This is topic 15, limits involving infinity. So today we're going to talk about limits that go to either infinity or infinity themselves. So if you look at this, the definition says the line x is equal to 1 is called a vertical asymptote if one of the following is true. Okay, so if you have something, if you have a limit of f of x as x goes to negative a, notice that, for example, it's actually telling you here that it goes to infinity. So I don't really know where it starts, but I know that I'm going to go up forever like that. Okay, but also if you have the limit as x goes to a from the right side, all right, so from this side, so from this right side you also go into infinity, and therefore the limit of f of x as x goes to a would be infinity. All right, so that would basically mean that both of these would be going up. So again, the definition is very similar to what we talked about in the past. If the limit from the left and the limit from the right are the same value, then your limit at that point would be that the value that's equivalent to those two. Okay. So that'll be that one right there. So that's the definition of vertical asymptote. Alternatively, though, if you have a limit from the left that's going to negative infinity, and the limit from the right is also going to negative infinity, then the limit as x approaches a being any number you can think of, would be negative infinity. All right, so for the purpose of the next test, so if you see something like this, like they're asking you, you know that this is going to go to infinity, all right, then you need to make sure you look at the value from the left and the limit from the right and see if they're both approaching negative infinity, then the answer is negative infinity. If they're both approaching positive infinity, then the answer is positive infinity. However, if one of them is approaching positive infinity and the other one is approaching negative infinity, then the answer still does not exist. All right, so this is a good example of this, would be this equation. So assuming you didn't have a calculator, right, so you don't know exactly what this looks like, although you should have an idea, right, just by the horizontal asymptote rules or the vertical asymptote. Notice that I hope you notice you have a vertical asymptote but x is equal to 1. But if you don't, that's fine. The first thing I would do always, is to save me some time, is I would try to find out if I could somehow cancel any of this to make my equation a little bit easier. Alright, and in that case I can't. There's nothing I can cancel, so I'm going to have to do it the hard way. Alright, so the first thing we're going to find is the limit as x goes to 1 from the left side. Alright, notice that the left side, the little sign goes on the right of the number. Alright, of f of x. Alright, so guys, notice that I do know, here's what I do know. I know that I have a vertical asymptote by 1. So assuming this is 1, you're going to have some kind of vertical asymptote there. Okay? So what you're going to do here is you're going to plug in points to the left of 1. Alright, so let me put a table here. So I have x, y here, or x, f of x. So I'm going to plug in a couple of points that are to the left. Alright, so this is, notice that 0 is to the left of 1 and negative 1 is to the left of 1. Alright, so I'm picking points that are to the left of this line. Alright, at that point, what I have to do is just plug them in. Alright, so assuming I don't have a calculator, I would have to, plug in negative 1 squared minus 3 times negative 1 over negative 1 minus 1. Alright, and that's actually going to give you negative 2. Oh, I'm going to write it over here. It's going to give you negative 2. Alright, so this one's negative 2. Alright, if you plug in a 0, for example, notice if I plug in a 0 here, alright, I want to have 0 minus 0, so over negative 1. So 0 over negative 1 is still 0. So that's going to give me 0 there. And therefore, notice that you're going up. Alright, notice that this is the farthest y value, so negative 1. So assuming that 0, negative 1 right there is negative 2. So let's say the negative 2 is right here, and the other point is here. So as I'm coming from the left, notice that I'm going up. Alright, and that automatically tells me that the answer has to be positive infinity. You can plug in more points if you like. Or you can plug in more points if you like. to convince yourself. The reality is that if from left to right you're going up, then the answer is going to be positive infinity. All right. Now, as the limit as x goes to 1 from the right side of f of x, all right, we're going to try to find that out, and we're going to do the same method. We're going to look for 2 points. All right. I'm going to pick 2 and 3. So I'm going to pick those 2 points. Okay. So let's see here. I'm going to put a 2 here and a 3. All right, notice these are points to the right. So 2 and 3, let's say if I plug in a 2, and you can do this on your own time here, but if you plug in a 2, you're going to get negative 2. All right, and if you plug in a positive 3 into this, you would get 0. All right, so again, those 2 points would be, let's see, 2, negative 2, and 3, 0. All right, now don't lose sight, all right? On this one right here, notice that on this one I'm going from left, right? I'm coming from the left. This is the limit coming from the left. Now on this one I have the limit coming from the right, and notice that the limit coming from the right, I actually have to go like this, meaning I'm actually going down. All right, so this one is negative infinity. Okay, so therefore, because the limit from the left is positive infinity and the limit from the right is negative infinity, that the answer to this is D and E does not exist, because one of them is going to positive, the other one's going to negative infinity. Therefore, they're not the same, so it does not exist. All right, so again, make sure you understand that drawing yourself a graph would probably be the best idea, but again, I know that on this one, because my values are actually going from here to here, I'm actually going up, my y values are going up, then that's going to be positive infinity. And on this one, because my y values are going down as I'm coming from the right, all right, so notice that that's 3, 0, and that's 2, negative 2, and therefore this is negative infinity. Okay? I guess at worst, if you have a calculator, you can try to graph it just to make sure you're right. Notice that that's going to positive infinity, the other one's going to negative infinity. All right, so that is pretty much all you can do. I would only recommend this to check it. I don't think you have that many problems where you have to do this. So try to do it by hand, and if you have to, check it with a calculator. Okay. Now let's go to the back. Now the back, I'm going to show you a couple of things. All right, then I'm going to show you a really easy way to do it. Now, the limit as x goes to infinity or negative infinity. So notice, this is the limit as x goes to infinity. So what we're going to do first is we're going to start out by dividing by the highest exponential power. All right, so every term on here, I'm going to rewrite this. Limit as x goes to infinity. And I have 3x squared. And I'm going to divide this 3x squared by the highest power. Okay, that's on this rational function, which in this case is x squared. So I'm going to divide this by x squared plus 2x over x squared minus 3 over x squared. So again, notice that all of these three, I've divided each one by the highest exponential power, which in this case is x squared. All right, over 2x squared over x squared plus x over x squared minus 2 over x squared. Okay, now here's the idea though. Okay, so notice that if I have x squared over x squared, well, that's going to cancel. That's just going to be 1, and that's going to be 1. All right, so that's not a problem. But here, okay, if you have the limit as x goes to infinity, think about it this way. All right, if you have 2 times infinity, but on the bottom you have infinity squared, you have a really large number squared, the bottom of this fraction right here is going to grow faster than the top of this, a lot faster. And because of that, as you keep going, as this number keeps getting bigger, this number on the bottom gets bigger faster than the number on the top. And because of that, that's going to be 0. All right, that's basically dividing by a large number. This one right here would be easier. This is just a number over infinity square, or to put it a different way, a really large number square, that's also going to be 0. All right, same thing one more time. if you have a large number, but on the bottom of that you have a large number squared, it's going to get a lot bigger on the bottom. And if you have a fraction and you have a really big number on the bottom, this is also going to be 0. Right? And same thing on this one. If you have a number over a really large number squared, then that's going to approach 0. Right? It's going to get really close to 0. So we can say it's close enough to 0, so we can say it's 0. Alright, so notice that all I have left is 3/2. Just like that. Alright, on the next part, we have the limit as x approaches infinity. Alright, so we're going to do the same thing. We're going to look for the highest exponential power. The highest exponential power here is going to be x squared. So we have, excuse me, let me erase that. We have 2x over x squared minus 3 over x squared over 2x squared plus x minus 2, and I'm going to divide each one of these by x squared. Alright, so please notice that at this point what we can do is the same idea as the limit goes to infinity. Alright, as x goes to infinity, this number on the bottom gets a lot bigger. So this is going to be 0. Right, on this side it's going to be the same thing. This is going to get really large really fast. So this is going to be 0. The bottom of that, by the way, is going to get really large. The top is still going to be 3. 3 over a really large number is still going to be 0, or very close to 0. Alright, so on this one, if you have this is just going to cancel, so notice that's just going to be 2. On this one again, if you have an infinity or a number really large on the bottom square and the top is just a really large number, it's going to get bigger faster on the bottom. So therefore, this is also going to be 0, and this is going to be 0. Right, so notice all I have left now is I have 0, everything on the top was 0, and everything on the bottom was just a 2. Right, so you have 0 over 2, which is just 0. So the limit of this would just be 0. Alright, and let's do one more here. I know this is getting repetitive, but I'm just going to show you the 3 different cases here. So we have the limit as x goes to infinity of 3x to the 4th plus 2x minus 3. Now let's look for our highest power. In this case, it's going to be x to the 4th. Plus x minus 2. So on this one again, I'm going to divide by x to the 4th. Alright, notice that on this one, alright, by the same reasons I'm talking about earlier, this is, this is going to cancel here, but this is going to be 0, that's going to be 0, this is going to be 0, that's going to be 0, and this is going to be 0. So on this one, I would have 3 over 0, which is undefined, which means the limit as x goes to infinity does not exist. Okay, so here are the good news. Alright, on your homework, alright, I don't want you to do it like this, because I'm hoping you're noticing a pattern here, especially with these numbers here that I have. If you look at these 3 numbers and I look at this original equation, this is actually the horizontal asymptote. Right, so notice that if I use the rules that you remember from pre-cal, alright, if I have the same power here, the same degree, then the coefficients are the answer, right? So the coefficient of x squared on the top is 3, the coefficient on the bottom of x squared is 2, so the answer is 3/2. If you just use the horizontal asymptote rule on this one, it's bigger on bottom, right? And if it's bigger on bottom, y is equal to 0. Alright, and finally on this one's bigger on top, right? So the answer, if you remember, was undefined, right? So in general, for your homework, don't write me this. Alright, if you have a limit going to infinity, what you're going to do is you're going to use the horizontal asymptote rules. Alright, so the limit as x goes to infinity is the horizontal asymptote. And this is one of the problems that for most kids in calculus last year, they had an easy time doing this because it was easy. All you have to remember is the horizontal asymptote rules, and you know the answer to this. All right, so again, on your homework, when you have a limit going to infinity, all right, when you have a limit going to infinity, that the answer is your horizontal asymptote. All right, if you got any questions, make sure and ask. We'll see you in class.